What are black holes? Are they even real? Do black holes really suck everything? Are black holes even of any use? Well, if you're curious, then let's find out. So, without any further ado, let's begin. If you do not know how black holes are formed, you can watch my video on the life cycle of stars, linked in the cards and the description. But here is a gist anyway. Very large stars explode during the end of their life, and most of their material is thrown into space. But the core of the star compresses into a black hole. Black holes are formed of the larger stars only because the small stars don't have enough mass. Now, black holes are regions where the force of gravity is so strong that nothing, not even light, can escape from it. Their extremely strong force of gravity is the primary reason they are considered to suck everything. But the truth is that they do not suck. Suction is caused by pulling an object into a vacuum, something a black hole is definitely not. Instead, nearby gas and dust falls into them. To understand why black holes just don't suck, we must understand the structure of a black hole. The accretion disk consists of superheated gas and dust whirling around the black hole in immense speed. This is important because this is the layer which can be spotted, thus showing the location of black holes. The edge of this disk is the last point where materials can orbit safely without reaching the point of no return. The black hole itself is dark, but it does emit light in the form of photons. This layer within the accretion disk is called the photon sphere. Now it is after the accretion disk that the real deal begins. We have the event horizon next, which is where the escape velocity exceeds the speed of light. In short, nothing can escape once it reaches the event horizon. To quote Avi Loeb, chair of astronomy at Harvard University, the event horizon is the ultimate prison wall. One can get in but never get out. Finally, we reach the singularity, the very center of a black hole where every object is infinitely small and infinitely dense. This is where even Einstein's mathematics begin to break down. So we understand that once an object passes the accretion disk, it can never return. Before that, it is relatively safe. So materials float towards these black holes and are soon absorbed and compressed into a singularity. So black holes don't really suck, but they actually absorb materials floating towards them. Now here is a fact that you might find interesting. The entire Milky Way galaxy, the galaxy where you and I live, is revolving around a supermassive black hole. Yes, just like the planets in the solar system revolving around the sun, the various stars and other star systems revolve around a black hole. So if it weren't for the black holes, the stars would not be revolving and would be floating around in outer space indefinitely. In simple words, black holes are the center of galaxies and keep entire galaxies stable. Supermassive black holes are really big. That's pretty much self-explanatory. But most black holes are small and are called stellar black holes. Black holes are very dense. In fact, they are so dense that the star, the size of the sun, would have to be compressed to the size of a town, and a star the size of the earth would have to be compressed to the size of a peanut in order to become a black hole. Supermassive black holes are usually formed when larger black holes engulf smaller black holes in order to become even larger. Now, I must clarify that all the information I have conveyed to you in this video is taken from reliable sources linked in the description. Here is a summary of the entire video. You can pause to read it or take a screenshot. I hope you liked this video. If you did, then please smash the like button, share this video, and don't forget to subscribe for more such videos every Thursday. Thanks for watching.